Hello, everybody. My name is Jordan Schaus. I'm an application engineer here at Xair, and welcome to the fall 2023 installment of Xair's webinar series. Today's topic is optimize your compressed air use by turning it off. We're gonna hang out just for like 30 more seconds. We've got some people trying to join in here, and we will hit the ground running. All right, let's do it. So couple presentation housekeeping items. If you're new to GoToWebinar, if you have any questions throughout the presentation, on the right-hand side of your screen, you should have a little pop-out like that, like you see shown there. Feel free to ask any questions. This can be found on the bottom of that pop-out during the presentation. I'll make some time at the end to answer a lot of those questions, but if you encounter any issues with the video, the audio, please let us know there, and we'll do our best to fix the problem. I do have my colleague Russ Bowman on the line as well, kind of in the background. He'll answer a few of those questions as they come in and try to help you troubleshoot as well. First, a little bit about myself. My name is Jordan Schaus. I'm one of the application engineers here at Xair. I joined the team in August of 2018. Before that, I spent my time in the metrology field, where I examined customers' quality processes and designed and implemented a strategy to better their quality and reduce scrap across the board. I was lucky to find myself in many different manufacturing facilities over those years. So I've seen compressed air used in countless ways. Some good, often some very inefficiently. So it wasn't until I started my time here at Xair where I found out how easy it is for a simple change that can help facilities save thousands and really reduce their compressed air generation cost pretty easily. But enough about me. Let's talk about Xair for a moment. We are a manufacturer, seller, and global distributor of engineered point-of-use compressed air products. We are located in the northeast corner of Cincinnati, Ohio, where we are founded in 1983. All product designs focus on the efficient and safe use of compressed air. Our products are commonly used in blow-off, cooling, cleaning, static elimination, and conveying processes. In fact, you may be familiar with some of our products like super air nozzles, super air knives, vortex tubes, cabinet coolers, and our full line of industrial vacuums, just to name a few. We offer the largest selection of point-of-use compressed air products on the market today, and we pride ourselves in being subject matter experts and available at a simple phone call any time of the day. Today's webinar is going to be about optimizing your compressed air use by turning it off. My goal for this webinar is to help you understand benefits and advantages of controlling a compressed air system by turning it off when it's not in use or unneeded. Gain knowledge of strategies for turning compressed air off when not in use, and learn how to calculate air savings when you turn it off based off duty cycle. And then for those attendees who have KGI CCAS certification, today you'll earn a certificate of completion in 1 PDH unit. Let me just check questions here just real fast, make sure we don't have any issues. Fantastic. All right. So why does it matter? Why are we here today? Why have you tuned into this webinar? You mentioned utilities like electricity, natural gas, water. Those are the main ones that come to mind. But in industry, compressed air is often referred to as the fourth utility due to the cost to generate, use, and maintain the systems. But when you use it appropriately, compressed air has many energy saving and environmental benefits as well. Compressed air is the energy of choice to power a great variety of applications and processes that would be inefficient or not possible without it. If you walk into your facility during a shutdown and you hear blow-offs running, That's equivalent to a leak in your compressed air system. And compressed air challenge tells us even a leak as small as 1/16 of an inch can cost you up to $523 a year. So again, why does it matter? It matters because when you add all that up, real leaks, unneeded energized blow-offs across your entire system, it costs thousands of dollars a year for something not increasing production and ultimately reducing your profit, as it's not being used for the benefit that it's meant for. When I think about the method of turning a compressed air operation off, I like to think of it as a bottom to top approach. If anyone is familiar with the hierarchy of controls, it is a NIOSH-led national initiative called Prevention Through Design to prevent and reduce occupational injuries, illnesses, and fatalities. While that's not our topic today, the bottom to top approach is a great way to visualize the least effective to the most effective way to attack an application for compressed air use. For example's sake, if you had an operation where an employee had to use an air blow off to help material move down a conveyor belt, the easier and least effective way to make that safe for the operator would to be give him safety glasses and earplugs. But the most effective way would be completely remove that operation by addressing the root cause of the product sticking, like treating a static charge upstream or making sure a belt is clean. So we took some inspiration from that and created a graphic of our own. From the bottom up, they go from least to most effective way to reduce the use of compressed air during times it's not needed for the design application. At the bottom there, you'll see manual valves like ball valves, next solenoid valves. In the middle, out-of-box control, flow control devices, integrating it into a fully written PLC program, and at the tippy top, the removal of the blow-off operation. So ball valves, manual valves, gate valves, butterfly valves, axial valves, they're great for applications where compressed air is needed for a long duration, and you're not shutting that compressed air off frequently, such as the end of a shift, but you are still relying on an operator to turn that valve when the compressed air application is no longer needed. While this is the typical cheapest and easiest way to add some control to your compressed air system for any given application, your cost savings is limited to the if question. Is if the operator turns that valve, you'll get the value out of that product. For example, ball valves work great for applications like this. A customer with an operation where they are using a small air nozzle to help parts move as they process around a vibratory bowl feeder. The operation, though, was only used for 8 hours on first shift. The customer figured out this operation was blowing 24/7 when they had an overnight maintenance shutdown and heard it blowing freely while the operation and production line was down. So they added a manual valve to the compressed air supply line and added shutting it off at the end of the day to the operator's daily procedure list. Assuming the valve did get closed every day, they went from spending $9 a day to $3 a day in compressed air generation cost. So a $20 ball valve saved them just over $1,500 a year. And of course, this is assuming that valve does get closed every day. As we know, stuff on daily procedures don't always get done. So there is some variable there that you can't control. Solenoid valves. For a more hands-off approach, you can have a solenoid valve that would tie into your existing PLC, e-stop circuit, or motor control to your compressed air line to aid in turning that compressed air on and off. Solenoid valves take that if your operator closes a valve out of the equation and leaves you with the savings when the compressed air is turned off by the command you've chosen. One example of this is a customer who makes donuts. Once they fried the donuts, they went through a heavy coating of glaze, but they wanted a way to thin that glaze out and ensure that they were still very evenly coated. The belt was 48 inches, so they used a 316 48-inch super air knife to complete this application. The knife worked great. That knife consumed 110.4 SCFM at the running pressure of 60, which is what they had it set to. Due to the process and the frequent changeovers, there would be long stretches of time when the glaze line wasn't moving. So they installed a solenoid valve tied to the motor that moved that belt. When the motor got power to turn on, so did the solenoid valve, and it opened. So when the system stopped, the belt for any reason, the air knife would also turn off. And when it started back up, the air knife would be turned back on. On average, they calculated for every hour of production, the glazer belt was off for 15 minutes. So turning that knife off for 15 minutes every hour saved 1,656 standard cubic feet of air for every hour, saving them $6.62 every day and over $1,700 a year in savings based off of their 260 working days. In applications where a product is traveling on a conveyor and must be dried, cooled, or cleaned, there's likely some spacing in between the parts. It isn't necessary to keep the blow-off running constantly if there are periods of intermittent spacing. To help reduce the overall load on the compressor, implementing a solution to shut the air off in between each part can have a dramatic impact on cost savings. Out-of-the-box flow control systems, like Xair's electronic flow control, we also call it the EFC, is designed to improve efficiency by reducing overall compressed air usage. It utilizes a photoelectric sensor that detects when the part is present. When it's not, it triggers a solenoid valve to close and shut off the compressed air supply. So you're saving when the operation isn't running at all, and you're also saving air between products when it's not needed for the desired outcome. So a manufacturer of car bumpers, they were using a 60-inch super ion air knife supplied at 40 psig to simply remove dust that was statically clung to the part prior to a painting operation. The bumpers were moving at about 10 feet per minute and had varying amount of space between each part. On average, the bumpers are only under the blow-off for around 10 seconds, while 6 seconds pass with no part present. With a 3-shift operation, this translated to 1,440 minutes of nonstop compressed air usage per day. So at 102 SCFM at 40 psig, their current method was totaling over 146,000 standard cubic feet. With the electronic flow control, or the EFC, installed, the air was shut off for 6 seconds, reducing the overall airflow by 37.5%. With the EFC installed, the compressed air consumption per day was reduced to just over 91,000 standard cubic feet. And as a rule of thumb, compressed air costs around 25 cents per 1,000 standard cubic foot of air. By saving 55,000 standard cubic feet per day, this manufacturer was able to save nearly $14 per day. Since this was a 24-hour, 7 days a week operation, the total savings for a year came just over $5,000. This easily recouped the cost of the EFC and then began to pay for itself in less than 6 months. PLC programs are close to the top level of control. Not only can you build the process to fit your individual application, you can also make adjustments easier over time if the process changes. A PLC program can also use feedback from both upstream and downstream of the process. For example, if a product fails an inline inspection, a compressed air nozzle can be activated to blow the failed material into a scrap bin upstream. Or downstream, they only use water to cool a part if its temperature reaches a set point. There would be no reason to turn the air on for every product, just the products that have been cooled by water to dry them off. A PLC can keep track of that data, control a solenoid valve to open and close based off of the wet part. The GIF to the right shows a simple program that's feeding a part into a blow-off station. And all the while, the PLC is tracking the piston locations, when the hopper is full, and part locations. These are all applications that traditionally are handled by an operator. Cost savings when it comes to compressed air would be similar to the out-of-box controller if you already have a PLC system in place. But the opportunity to integrate several tasks into one PLC program makes the cost-saving possibility endless. From helping identify and remove scrap to completely removing an operator from an application. not to mention the added control and repeatability a PLC offers in your process. The best way to reduce compressed air generation costs is to not use it. However, that isn't always possible or as easy as it sounds. Elimination, while most effective at reducing compressed air use, also tends to be the most difficult to implement in an existing process that requires the rugged and on-demand use of compressed air. If the process is still at the design or developmental phase, elimination of the compressed air could be inexpensive and simple to implement. But for an existing process, major changes in the equipment and process may be required to eliminate or substitute. And a lot of the times, compressed air does end up being the best thing for the job, so elimination isn't always the best option. But controlling and using it efficiently is the most important thing to consider when designing an operation that uses compressed air. By turning off your compressed air, whether it be with a manual valve or an automated controller, a company can minimize wasted compressed air use and extend the longevity of air compressor and air compressor systems, resulting in overall energy use reduction and money savings. Well, that's everything I wanted to cover for the day. The benefits and advantages of turning the compressed air off when it's not in use, understanding the pros and cons of 5 different control methods, and understanding the cost savings that go along with each. I'll open the floor up and take a look at some questions we may have, and I can answer those live here. Hang with me here. Here we go. EFC. Can you change the control modes of the EFC? Yes. So actually, the EFC, the electronic flow control, there are 8 different control modes that are kind of pre-built into the EFC, along with some timing changes and delays as well. From factory, it comes with a what we call the signal off delay. This is where the sensor will detect the part. It'll open the valve immediately, so it creates that blow off operation. Then the timer will begin at that point. To turn it off, essentially, once that part has cleared that sensor, that timer will begin and it'll turn that blow off and close that solenoid valve. But there are, like I said, 8 different control methods, time variants. There's a lot of options you can do with the EFC. Actually, on the side of your GoToWebinars panel there is a handout section. If you drop that little window down, you'll see there's two handouts. There's an optimization PDF. That's our optimization catalog section. So that'll cover the EFC, and then also the installation and maintenance guide that will go over those 8 different control methods. All right, I don't see anything else coming in. I appreciate everyone's time today. I will, if you have your KGI and you're looking for the certification, those will be going out, if not this evening, most likely tomorrow. If you have any questions, feel free to reach out to us. As I mentioned, XR has an entire team of well-trained application engineers ready to assist you with any of your applications. There's all of our information. Feel free to shoot us an email, give us a call. We also have a fancy chat function on our website as well, where you can pop in and talk to one of us. Sometimes you'll get me, sometimes you'll get Russ. So I appreciate it, and thank you for your time, and have a great rest of your day.